Okay, so everyone, so now we'll start our presentation. Yeah, it's a pleasure to have the chance to talk to you about our mobility matching application, Match&Go, not Touch and Go, or Suica service. Okay, so this is our team member. I'm Koki Somura, and I will talk about our ideas business model. After that, Mr. Yuya Kato will explain you how our application works. And after that, Mr. Cho will answer your questions. Okay, so now, here's our agendas, but today we will skip this slide. Okay, so please imagine that you live in a small local city in Japan. So you want to take a bus, but you have to wait for a very long time. As you know, public transportation in local cities is not so convenient. So it's very inconvenient. So you will choose not to use transportation system. As a result, limited number of empty buses run local cities every day. Empty buses is very inefficient style. Instead, you may choose to use your private car. But as you can imagine, you will be caught in severe traffic jams. It's also trouble. So, as you can see, our issues are these 2 points. Mismatch of supply and demand, and negative cycle into management difficulties. Okay, so in order to solve these problems, so we will use this application. Yeah, and this is a mobility matching tool for smartphone. Yeah, as you can see, we adapt very simple user interface, so targeting everyone. In addition, this application provides comprehensive route matching service, including on-demand transportation service. Also, this application proposes your most appropriate way to your destination. So you can visit wherever you want at any time. Also, you can book on-demand transportation service all at once. So traditionally, we have to open lots of applications in order to decide which way to go. But today, our application provides comprehensive route service. So just using our application, you can decide the best appropriate way to visit your destination. Okay, so this is a business method of us: sponsorship, subscription, data analysis and monetization, and premium plans. Yeah, so this is a business model. We get sponsorship from local governments. In fact, today, a lot of local cities have started sponsoring these on-demand transportation service. So this trend becomes stronger and stronger. And we get subscription fee from users, and also we can get a lot of fee from monetization of data and premium plans. Yeah, and next we will talk about our market size. Yeah, so from 2024, we will get 3 times larger than that, 3 times larger market size in 2030. Yeah, this estimate based on CAGR. In this field, it is estimated that 19.21%. And we don't start our business in nationwide. We will start from small special area, Hoshigaya City in Saipan Prefecture. Yeah, this is our hometown and research area of Mr. Cho. So we are very familiar with this area. So now, Mr. Kato will explain you how our application works. Please start.
Okay, let me talk about the system we are actually going to provide. As mentioned earlier, based on inputs such as time, location, and task, we will select the mode of transportation for the user. If the selected mode includes a taxi, or if walking takes too long, for instance, we will present on-demand transportation as an option. For on-demand transportation, we are looking at ways to make getting a ride easier and more efficient. This means figuring out the best spot for cars to wait and the quickest route to take. Our goal is to cut costs without sacrificing comfort for passengers. We think using AI can help us do this by crunching data on where people need rides, how busy the roads are, and other factors. By doing this, we can offer a smoother and faster service to our customers. We are focusing on using AI as a means of optimization. The diagram below attempts to optimize vehicle dispatch in a model city. We use clustering, a machine learning technique, for this computation. The green points represent places where people could appear, assuming people will randomly appear from 3 out of 6 of these locations. The purple marks shows the optimal dispatch position based on these assumptions. Okay. You can see that the delivered optimal position for vehicle placement aligned to some extent with intuition. However, applying this to real-world data in an actual city presents challenges. In our simple model, we are devising optimal dispatch based on the assumption that travel distance and time have a simple proportional relationship. However, in the real world, factors affecting travel time go beyond just distance. Considerations such as traffic congestion, signal times, and the time of travel are all factors. Crafting algorithms to account for all of these factors and derive optimal dispatch and routes manually is not easy. Therefore, we propose using reinforcement learning to derive optimal dispatch and routes based on various factors. By providing AI with data such as traffic volume for each route, data on locations where customers appear, and nearby ETC data, and setting rewards to be inversely proportional to time, we believe we can optimize vehicle dispatching and routes in complex real-world scenarios. We aim to provide this derived data to drivers operating on-demand transportation to achieve a comfortable service. Next, I will introduce an image of the actual implementation of the functional problem. First, let me introduce the interface for users. Users start by entering their schedule into Google Calendar. For example, if they are planning to travel to Hongo thank you for your listening.
I'm sorry. Thank you for the presentation. So now